Hey everyone, my name is HIDAYAH binti ROHIMI. My magic number is 241110985. So today I'm going to show you my video for lab 2. So I'm doing the experiment for lab 2, which is about signal characteristic. So in my lab 2, my research question for lab 2 is how do different distance. So I choose 0 cm, 10 cm, 20 cm, 30 cm. So I would like to see if this distance, a different distance, can affect the highest magnitude for a 1300 Hz sound. So in my experiment, we have independent variable and also dependent variable. So independent variable is maximum. We need to see the maximum patch magnitude that we get from the software. So software that I using in this experiment is Scilab, and my independent variable is distance from my sensor to the speaker. So this is my speaker for my laptop. Hypothesis that I got from doing this experiment, if the distance increase, then the signal magnitude will be decreased because the sound get spread out and travel far away through the air. This is a equipment that I using for my experiment lab 2. So I have a ruler, my iPad for sensor, and sound source I using my laptop. Okay, now let me show you my experiment setup on my desk. For this desk, I'm using a laptop to play the sound, and I'm using my iPad to record the sound. So, and after that, I use a long rule to measure the distance. So I can play the sound at the constant volume level. I choose 7. So for my first test, I played the iPad directly touching the laptop speaker. So this is laptop speaker. So I touch 40 cm. So I will play the sound and record it. So next, I use a ruler for 10 seconds to move the iPad. After that, I will repeat the step with 20 cm and 30 cm. To keep the test got a fair and a good result, so the room is completely quiet, so we no fans run, and also my position stand back behind the camera and stay very far away from the laptop, so I cannot block the sound with. After I finish recording, I send this file to my laptop, and then I convert this file in MA4. So I convert to WAV format, so easy for Scilab to read. Okay, now I'm using the Scilab software to generate the graph. So I already paste my coding. So the first one, you choose the execute file with echo. So I start from 0 cm first. So now if you guys can see, two graphs have already be generated. So the red graph line is the frequency domain. Look at this top pad. So it show at 1000 Hz. The magnitude is near 20 because the speaker is very close to the microphone sensor. Okay, look at the 10 centimeter density. The blue waves is very messy for the line graph. The higher pad moved to the 8000 Hz. The magnitude dropped down to the 0.158 because maybe the microphone picked up a noise room. Okay, right now we jump to the 20 centimeter density. So just focus on FFT graph. So we see the hour sound is gone and the higher pad at 300 Hz. So the magnitude is only 0.11. This is just a low room noise. So for the last is 30 centimeter. So the highest pad is also at a far less, around 152 Hz, and the magnitude is 0.19. At this distance very long, so maybe they pick the background noise on the room too.
Okay, now look at the simple table that I already made. At 0 centimeter, the sound is a very strong at 20, but at the 10, 20, and 30 centimeter density, the true sound disappear. So the graph only shows more room noise under a 0.20. So the data support my hypothesis. If the distance increase, then the sound magnitude will be decreased. This happen because sound lose energy when it travel through the air. So error for my experiment is uh, the room is not there for perfectly quiet because microphones they pick a background noise. Even though I already do the experiment at the midnight when all people already sleep, but they have noise from maybe from my laptop fan and from the room environment. So this is why I see the shrink back at 20 and 30 centimeter. So I think this experiment success connect back to my research question. So I found that distance change the sound with a characteristic. So greater distance make the sound weaker.